your regressions down into 4 steps. Okay, these are the 4 steps that we're going to repeat all the way through. So step 1 is going to be enter the data set. Okay, and where we enter the data set is on here. If you look, you'll see a button called Stat. You hit Stat, then you hit Edit. You can see that it brings up multiple lists, right? You have L1, L2, L3, L4. I think it goes all the way to 6. Those are just placeholders, right? Those are columns. But we're going to enter the data set. Okay, step 2 is to run the regression. Okay. And when we run the regression, this gives us our model function or our modeling function. And then step 3 is to use the modeling function to calculate a new, use the modeling function to find expected values, we'll call it. Because typically it's always going to be out in front, okay, way beyond. All right, so those are the 3 steps that we're going to use and use repeated. The only thing that really changes between an exponential and a logarithmic growth is step 2. Instead of running exponential regression, we run natural log regression. Okay, I know we've done these just a little bit before, but that was way back in the first semester. So it's always nice. And like I said, this is probably one of the most useful things that a TI-83 can do for you. Like you could actually model your profits of a business this same exact way as long as you have data sets. Okay, you can model anything with the data set. Okay, so let's look at our data. Okay, it says bacteria, the growth of a culture of bacteria is shown in the table. Use the exponential regression to model the data, then use your model to predict how many bacteria there will be after 24 hours. Okay, and we're given this little table right here. So for my hours, I'm going to enter that into L1. And for my bacteria, I'm going to enter that into L2. Okay, and the reason I'm doing that is because those are set up standard on your TI-83. If I were to go to second stat plot here, and click on plot 1, you can see that the X list is set up as L1 right there where it's beeping, and the Y list is set up as L2. Okay, that's because your hours are your inputs or your independent variables, where your Y values are your dependent variables. So, and once again, I check that by hitting, oh, don't do that. Second, enter, second quit. I checked it, you hit second, and then Y equals brings you to this screen. Then you can hit enter. You can see I've turned the plot on, all that good stuff. So I am ready to enter my data. So to enter the data, I hit stat, and then I go to edit. Like I said, I'm going to be exclusively using L1 and L2. L1 is reserved for the hours. So 0, 1, 2, 3, 4, 5, 6. Just like that. If I hit arrow to the right. Now the key is to be detailed. Okay, you don't want to mix up your X and Y's, or you don't want to have them misstated or out of order, because that'll throw off your regression. So now we enter L2, and you got to hit enter after each one. All right, so now I've got it all entered. I'm going to double check to make sure it's right. Just making sure. 800, 950, 1130. Perfect. 0, 1, 2, 3, 4, 5, 6. Awesome. So the cool thing is, I've already adjusted my window, or I thought I did. So X min is going to be 0. X max is going to be 25. Y min, I'm going to be 0. I'm going to put that to 2500 and counting by 50s. Hit graph, you can see that's kind of my scatter plot. That scatter plot is representative of the data that I entered into this list 1. And you can tell that it's on because plot 1 is on, right? And then if I went second stat plot, I can turn it on and off that way. But that's the data as it's entered and as it's presented. So that takes care of step 1, entering the data. Step 2, we got to run the regression. Okay. In order to run the regression, we click stat again, which is where we entered all the information. Now, if we go to calc, you can see it gives me a whole bunch of different regressions. Anything with reg in the back is a regression. So we have linear regression. We thought it was going to be a line. Quadratic regression is like for parabolas. Cubic for cube functions. Quartic regressions for polynomials with x to the 4th as a leading coefficient. It's quartic. There you have linear regression again. You have your natural log regression right there, which is any type of logarithmic. And then you have exponential regression. The problem called for us to use exponential regression. So we're always going to do what the problem tells us to do. Okay, if you hit enter on that, it'll bring you back to your home screen. Click enter again, it runs the regression. This is the part where this is your modeling function. So you can see it'll give you a generic display of how your function formats. So ours is y equals a times b to the x. So just a generic exponential function. But then you can see it puts in values for a and b. So a is 399.57. That's going to get rounded to 400. Okay, and then my 1.89, I'm going to round that to 1.19. So my equation that I'm going to be using 400 times the quantity of 1.19 to the x. Okay, and that's the completion of step 2. Once I have this information, I've written down my equation. I go back into y equals, and I want to enter that function into so that it'll graph. And if I hit graph, you can see that my modeling equation has modeled my data almost perfectly. Okay, so this one's right on. Now the key is they wanted us to figure out how many bacteria there will be after 24 hours. Okay, so if I hit second calc to go to where I would do like the calculating the zeros and the minimum and the maximum, if I click value, and if I put x at 24, or this one should be 25 because I had a 0 representative. Oh, no, it is 24. Value 24, just like that. You can see the value that it spits out is roughly about 26,012. 0.758. Okay, and basically what that whole process was gathering your data, running the regression to get your modeling function, and then using your modeling function to forecast what the expected amount is going to be. Okay, that's the beauty of regressions because it's a very repeatable process. You'll do that same thing each and every time. The toughest part is entering the data and then making sure that we're choosing the correct regression to run. Today, you're going to run all exponentials and logarithms. But we'll watch the books version. So we've given our data. Step one, they say make a scatter plot. That's entering your data into stat one and stat, or into list one and list two in the stat plots. Okay. And you can see that from looking at this, it looks like it's an exponential growth function. Okay, once we do that, then we run the exponential regression. Okay, that's the regression that they gave us, or that the calculator found fit the data the best. This R squared and R value, the closer it is to 1, the better your data matches the function. Okay, or better that your function matches the data. So exponential regression, you see it was 399.57 and then 1.189. Okay, so we graph the regression to make sure that it matches the scatter plot. And then we use the model to make a prediction. You can see that they've rounded to 400 times 1.19 to the T. And the bacteria population was about 26,013. Okay, and they used the calc function to find that. And that would be their answer. Bacteria's element of time, 400 times 1.19 to the T, about 26,013 bacteria after the 24th hour. Okay, so we'll do a couple more because, like I said, it's very process driven, but the process, it gets simpler, it gets easier, but it's a lot to wrap your head around the first time through. I will give you that, because the calculator can be kind of fussy every once in a while. So here's the question. It says the number of leaves falling per hour from the trees in the arboretum is shown in the table below. Use an exponential regression model to predict how many leaves will fall in the 10th hour. All right, so like I said, I like to use L1 and L2 exclusively. You could use L2 and L3. That's more than fine, but I'm very processed, so I'm clearing out the list. If you go to the top where you're selected onto L1, if you hit clear and then hit enter, you can see it'll clear it out right there. Oh, helps if you hit the right button. All right, so L1 is my list or my X values. So 1, 2, 3, 4, 5, just like that. L2 is my Y value. Okay, double check to make sure I got it in properly. 250, 270, 292, 315, 340. So we're all good there. Okay, if I want to view the stat plot, since I've left it on, you can see it's right there. Okay, so go stat, calc, exponential regression to get my modeling function. Okay, so it gives me 231 times 1.08 to the x. Insert that. Get your parentheses, Mr. Burns. Graph it. See, it models my data very well. Go second, calc, value, 10th hour. Right there, looks like it's 498. So the approximation that we're going to use is 500 because there was a slight rounding. So this one should be answer B for 500. All right, on to the next one. Logarithmic regression. There are two of these, and then we'll be done. Because like I said, it's the same process over and over and over again. It's just a matter of picking the correct regression. So a group of students studied a photograph for 30 seconds, beginning one day later. A test was given each day to test their memory of the photograph. The average score for each day is shown in the table below. So use a logarithmic regression to model the data, then use your model to predict the average test score after 2 weeks. So that's going to be 14 days. So step one, we want to enter our data. So we have days 1 through 7. Okay, and then we have the scores as a percentage. 2.3, 69.8, 2, 62. 5. All right, so step one's done. All my data is entered. Just want to double check to make sure that it's right. Boy, my modeling equation is not overstated or incorrect. Okay, that looks good. I can try. Let's see. Does that make it better, Rosalind? Okay, so to get to where you're entering the data, I'm going to just clear that out. Okay, so it's under stat. It's this button right there, stat, and then you click to edit. And then L1 is my X values, L2 is my Y values. Okay, so then once you have your data entered, you can click stat again, go to calc. This one, they ask for logarithmic regression. So we're going to use natural log regression right there. You click enter. Okay, and you can see my two values, A plus B times the natural log of X. So I'm going to make note of that. So that's 73.09 minus 7.31 times the natural log of X. So you can see the A, B values there. And I take that and I enter it in, 73.09 minus 7.31 log x. And I can hit graph. Ooh, I gotta adjust my scale. Window. Call that 100. Go to 15 there, see if we can get a better version of it. There's my data. You can see the modeling equation. Yeah, you hit stat again. Then you go to calc. Then you hit natural log regression. Okay, and then I have my graph right there. So calculate the value. Test score after 2 weeks. So day 14. Right there. So the average test score according to my data is 53.8.